In this video, we can explain a few concepts regarding temperature control. What is accuracy and what is precision? What is repeatability? This diagram best explains it. If you consider the bullseye here to be, in all these diagrams, to be the set point temperature, not accurate, not precise. You have these red dots all over the place. Not accurate but precise. So it's not close to the bullseye, but it's all within the same area here. And accurate but not precise, closer to the bullseye, but in different areas. And this is accurate and precise. Of course, most customers, especially those with a high need for accuracy and precision and stability, will definitely want something closer to this. Most of our brochures, not just us, but our competitors and across the industry, when you look at the temperature specifications for an incubator or an oven or any temperature control equipment, it'll always give you a range. You'll usually see ambient or RT plus 5 or a value to and another value. So on the right hand side, this will be the high range. So here in this case, it's 80 degrees Celsius. So that means the maximum temperature is 80 degrees Celsius. And on the left hand side here will be the low range, which is ambient plus 5 degrees. So if ambient was 25 degrees, that means your lowest control range will be 30 degrees to 80 degrees. And then you get something that says either accuracy or fluctuation in this case. And this means that at 37 degrees, the maximum fluctuation is 0.15 degrees. So that means if we set this incubator at 37 degrees, it'll be in a range of either 37 plus 0.15 or 37 minus 0.15. And that's the range where we can expect it to be more or less. If we are speaking to a customer, and especially customers with a very high need for temperature or have temperature sensitive samples, not every customer's need for temperature stability is this high, but especially when you deal with pharma, it's important to understand what sort of range they need and to see whether our equipment can meet the range. Another important concept that pops up is forced convection versus natural convection. So you might see this, most incubators or most of our competitors have options for forced convection and natural convection. And the difference is forced convection, generally there's a fan inside and it basically blows the air around and creates uniform temperature throughout. Remember that incubators have elements, some of them have elements in more than one side, but most of the time the elements is either in the back or the bottom, and you want to create an even flow of temperature. Forced convection creates airflow inside to a forced airflow to create even temperature. Natural convection relies on gravity. The hot air rises, cool air sinks, and to create a gravity flow to create temperature uniformity. So with the natural air convection or the natural convection airflow, it'll take a longer time to reach stability, but it's ideal for sensitive samples like airborne materials and reduces contamination. So it really depends on the customer's need and application, but probably 9 times out of 10, we quote forced convection incubators in our industry.